And the first objective is to determine the volume and density of glass block, and also we want to determine the density and volume of ball bearing.
So we will start from the introduction. The vernier caliper allows you to measure external thickness in millimeters and that of holes to a maximum of 150mm with a 0.05mm approximation. To measure outer dimensions of an object, the object is placed between the jaws, which are then moved together until they secure the object. The screw clamp may then be tightened. Ensure the reading does not change while the scale is being read. The first significant figures are read immediately to the left of the zero of the vernier scale, and the remaining digits are taken as the vernier scale division that lines up with any main scale division. This is because the sample may only appear to be regular, or it may deform when the caliper puts pressure on it. A better estimate of the measurement error can obtain by taking the difference between the minimum and the maximum measured value. The micrometer screw gauge is used to measure even smaller dimensions than the vernier calipers. It is a screw with an accurately constant pitch. The micrometers in our laboratory have a pitch of 0.50mm. The rotating timber is subdivided into 50 equal divisions. The timber passes through a frame that carries a millimeter scale grid of 0.5mm. The jaws can be adjusted by rotating the timber using the small racket cock. This includes a friction clutch which prevents too much jaws by 1mm. In order to measure an object, the object is placed between the jaws and the timber is rotated using the wrench until the object is secure. Note that the ratchet knob must be used to secure the object firmly between the jaws. The lock may be used to ensure that the timber does not rotate while you take the reading.
To calculate the volume of ball bearing is V equals to 4/3 pi r cube, and the formula we use to calculate the volume of glass block is length times width times height. The formula that we use to calculate the density of ball bearing and glass block is P equals to m/V. Based on the experiment that we have conducted, we are able to determine the volume and density of ball bearing, and we are able to determine the volume and density of glass block. The volume of ball bearing is 3.61 times 10 to the power of -6 meter cube, and the density of ball bearing is 7742.382 kilogram per meter cube. And the volume of glass block is 1.06 times 10 to the power of -4 meter cube, and the density of glass block is 2728.113 kilogram per meter cube.
On to our next experiment, which are experiment 5 titled Frictional Force. We'll be using mass, wooden block, and spring scale. It is to determine the coefficient of static friction of different surfaces.
I'm gonna talk about today. First one is measure the mass of wooden block recorded as M. Second one is set up the apparatus as shown in figure 5.2. The third one is make sure the tabletop is stable and horizontal to the ground. The fourth one is attach the spring scale and the wooden block with a string. Then place them horizontally on the tabletop. Make sure the rubber side of the block is faced downward. The fifth one is a mass, 50-gram mass on the wooden block. The sixth one is pull the string slowly once the block starts to move. Record the spring scales reading. Record the value as fx and tabulate in table 5.1. Seventh one is repeat step 4 until 5 for trials. One, add another 50-gram mass on the wooden block and repeat step 5 to 6. Repeat the steps until total of M 500-gram mass is on the wooden block.
Okay, so for the next one, we get to see the result. On the left side, we get to see the result of rubber surface, and on the right side, we have the non-rubber surface result.
Analysis experiment. First, draw and label the free body diagram of the wooden block. So this is the answer. Second, plot graph of static friction force against normal force for the rubber surface and non-rubber surface. This is for rubber surface and non-rubber surface plot graph. Third, use the gradient obtained from the graph to calculate the coefficient of static friction for each surface. We use y2 minus y1 divided by x2 minus x1 from the rubber surface and non-rubber surface graph output. Fourth, compare and discuss the coefficient of static friction obtained. Coefficient of static friction for rubber surface towards the floor is greater than the non-rubber surface. This because rubber surface generates higher frictional force than non-rubber surface. So we move to the next section, which is question. First question: how can anti-lock brakes stop a car in a shorter distance than regular brakes? The wheel speed sensor provides the ABS system with the essential information to determine rather than regular brakes. Wheel speed sensor, pressure, release valves, a hydraulic motor, and a controller. Second, from your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think? Determine the coefficient of static friction. So the answer is the maximum coefficient of static friction is on the wooden surface. It's aligned with our hypothesis, which asserts that the wood surface holds a higher coefficient of static friction compared to cement floor surface. The coefficient of static friction is indicated by the normal force of the object acting upon the surface. Wood surface exhibit more roughness than smooth cement floor surface. Consequently, the normal force exerted by the object on the wooden surface surpasses that on the cement floor surface. Hence, the force required to pull the object is also higher on the wooden surface than on the cement floor surface. Last question. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The answer was, it glides smoothly when the mass begins to slide. Yes, it encounters intermittent movement on both surfaces. This indicates that static friction reacts to our action. It increases to match and oppose the applied force. When we exert enough force, the crate appears to suddenly slide and initiate motion. At this point, static friction yields to kinetic friction. Once in motion, maintaining it is easier than initiating it, indicating that the kinetic frictional force is lower than the static frictional force. When we introduce additional mass to the crate, such as placing a box on top of it, you need to exert even more force to initiate movement and also to sustain it.
Okay, for the next one, we have this discussion. Okay, I will read the discussion for you. Based on the data we gathered, the graph representing the state of friction force Fs against normal force N for the rubber surface and non-rubber surface was plotted. From the plotted graph, the static friction force is proportional to the normal force. From the calculations that have been done, the coefficient of the static friction for the rubber surface graph is 1.22, whereas the graph of non-rubber surface has a coefficient of 0.4757. The formula that we use is Fr equal to mu S Fn. Lastly, the coefficient of static friction of the rubber surface is greater than the coefficient of non-rubber surface towards the floor. Since rubber surface are more elastic, they are able to expand the contact area and adapt to the irregularities of the floor. The intermolecular force between the rubber and the floor are strengthened by the larger contact area, which increase the coefficient of static friction. During the course of this experiment, certain errors may occur. Human errors during preparation, data collection, and analysis can all lead to inaccurate results. For instance, by misinterpreting the measurements or improperly configuring the experiments. These errors can be avoided by standardizing methods and double-checking data entry. Okay.
So lastly, we got the conclusion. So for the conclusion is, the force used in this experiment while pulling is inconsistent. A wooden block was attached without any rubber surface block and was pulled by a spring slowly. Meanwhile, the other side of the wood was attached to a rubber surface block. It shows that wooden block without any attachment creates a low static friction, while a wooden block with rubber surface creates a high friction force. This shows that the coefficient of static force with rubber surface is greater than the one without rubber surface. In conclusion, different surface play a huge role or influence the static friction force of an object.